Good morning or good afternoon. It's Miss Bauer here, and today we're going to talk about how to find the area of a regular polygon. Now, if you remember from the other day, we talked about polygons. Regular polygons are equilateral and equiangular. So, equilateral meaning that all the sides are congruent, and equiangular meaning that all the angles are congruent. So, keeping that in mind as we go through these problems, for example, if I asked you to find the area of this shape, well, this is a regular hexagon. I could use the same formula that I could use for this square or for this triangle, assuming that they're regular polygons. So what's nice is we have this formula that will work for any polygon, regardless of how many sides it has. This is going to allow us to find the area. The only catch is that it has to be a regular polygon. So the parts of a regular polygon are you have your sides, which you already know that, and you have your angles, you already know that as well. But we also have a radius and a regular polygon as well. So that's not just for circles anymore. The radius is what's always going, if I create more triangles within these shapes, the radius is the hypotenuse of that mini triangle inside of my polygon. I like to think of the radius as the one that runs away to the corner. It's like if I look at this square, I have those mini triangles. That radius is the hypotenuse. It's the one that's running away to the corner. Hexagon, same thing. I have all these little triangles. My radius is the hypotenuse, the one that's running away to the corner. The apothem is one of your legs. It's almost like it's the height of the shape, but not really. Like that's not really the height. That's not really the height either, but I like to think of apothem as like the height of the mini triangle and the radius like the hypotenuse of the mini triangle inside these regular polygons. So if it is a regular polygon, we can always use this shape, and that's at the area, capital A, is going to be 1/2 the apothem times the perimeter. So just keep in mind that the little a stands for apothem, the big A is the area, and that capital P stands for perimeter. Now, you wouldn't think that perimeter would be the thing that messes people up on these problems, but it really is. If you had a triangle and I told you that one side is 5, well, the perimeter would be 5 times 3, which is 15. If you have a square and one side is 10, then the perimeter would be 10 times 4, that's 40. If you had a hexagon and one of the sides was 2, well, then the perimeter would be 2 times 6, that's 12. So keep that in mind as we're going through these problems. Now, you don't have to even memorize this formula. You just have to know what each piece stands for, and it's actually on your chart. So it's actually on your colored formula chart for this unit right here on the back. Area equals 1/2 little AP, where the little a stands for the apothem and the capital P stands for the perimeter. So taking a look at these problems, I really just need to figure out what's the apothem, what's the perimeter, and then that's going to allow me to calculate the area. Don't cut out steps here. So for this first one, the apothem would be, remember it's not, that's the radius, the one that's running away. So my apothem would be 4. To find the perimeter, if one side's 8 and it's a square, we're going to assume that these are regular, so that would be 8 times 4. So the perimeter would be 32. So to find the area, I'm going to write out my formula. I'm not going to cut out steps, being sure to show my work. So area equals 1/2. Well, the apothem is 4 and the perimeter was 32. Not 8. That's where people tend to go wrong. Remember, perimeter is all the way around, all the way around. So if I ask myself, I could do 4 times 32 and half it, or to do this without a calculator, asking yourself, what's half of 4? Well, half of 4 is 2, and then what's 2 times 32? That would make the area of the square 64 units squared. Now, this was a square. You have other options to find the area. Oh, don't know what's happening with my iPad. You have other options to find the area of a square, but remember that this formula will always work regardless of how many sides it has, as long as it's a regular polygon. So for a square, that is regular, that is equilateral, equiangular, this formula works. Now, taking a look at a hexagon, so I have 6 sides. So be careful, I have 2 numbers now, so I have 20 and I have 10√3. Asking yourself, which one would be the apothem? Well, the apothem would be 10√3. And if I go to find the perimeter, I have a problem because I don't actually know the sides. I don't actually know the sides. Well, there is a special rule, and this works for hexagons and only hexagons. And that is, for a hexagon, the radius and the side are the same. And it goes back to this type of triangle right here. If I have a hexagon, I can divide a hexagon into 6 triangles. So if you think like all the way around is 360 divided by 6, what ends up happening is I end up creating a bunch of equilateral triangles. It only works for a hexagon because 360 divided by 6 is 60 degrees. And remember, in an equilateral, equiangular triangle, all the angles are 60. So the only shape that this works for is a hexagon. But if it is a hexagon, then your radius and your side are the same. So even though they didn't tell us, we know that it's a hexagon. The radius is 20, which means that all of your sides would be 20. So I'm going to give you a minute to figure out the perimeter there. Well, 20 times 6 would be 120. So I have the perimeter. So now I'm going to go find the area. So to find the area of this hexagon, I'm going to do 1/2 the apothem times the perimeter. Don't forget about the half. So I'm going to do 1/2. I'm going to leave this root 3 in my apothem because I want it to be as accurate as possible. So 1/2 10 root 3 times the perimeter is 120. So I can half it at the end or I can half it at the front. For this particular one, if I asked you what 10 times 120 is, that would be 1,200, and then I could half it. So just ask yourself, what's half of 1,200? Now, remember, what's out stays out, and what's in stays in, which is why when I have a radical, I'm going to deal with my numbers first. So 10 times 120 was 1,200. Half it, so that would be 600, and then what's in stays in. So the area of this hexagon would be 600 root 3 units squared. I don't know if we're talking inches, centimeters, or what, so that's why I'm doing that U for units squared. And that's it. So you pretty much just need to figure out what's the perimeter, what's the apothem, and then you can go from there. So if I take a look at this one, asking yourself, how many sides does it have? What shape is this? Well, 5 sides would be a pentagon. So to find the area of a pentagon, if it's regular hexagon, any shape that's regular, it would just be 1/2 the apothem times the perimeter. So area would be 1/2. And I don't have to fill in these boxes, but you can if you want to. So 1/2 the apothem would be 4. And then a lot of people say that the perimeter is 3. Be careful. I want you to think about that. Well, the perimeter is not 3. That's one side. So if one side is 3 and this is a pentagon, well, then the perimeter would be 15. And I like to try to do as much mental math as possible. So if you ask yourself, what's half of 4? Half of 4 would be 2. 2 times 15 would make the area of this pentagon 30 units squared. And that's how we find the area of regular polygons. Regardless of pentagon, hexagon, heptasecta, octagon, it does not matter. We should be fine either way. So let's take a look at just a few more. As long as you can figure out the perimeter apothem, you're good to go. So taking a look at this particular problem, so if I go to find area of a regular pentagon, I'm going to do 1/2 the apothem times the perimeter. So it's a little bit, my triangle's up top. It doesn't really matter. I could turn my paper around, but asking yourself, which one is the apothem? That would be this one, the one with the box, the leg. So that would be 1/2 the apothem, 6.5. And I have a problem when I go to do perimeter for this particular problem, and that's that I don't know the sides. And if you don't know the sides, then you can't find the perimeter. Now, we know that 8 is the radius, and if it were a hexagon, then I can use that rule. That would be great, but it's not a hexagon. So I'm going to take a closer look at this. I have this triangle. I know that the radius, I know the hypotenuse is 8, and I know that the apothem is 6.5. Could we find that piece right there? And if you remember from last unit, if it's a right triangle and we know 2 sides, we can do Pythagorean Theorem to find the next one. So I'm going to do x squared plus 6.5 squared equals 8 squared. I have the hypotenuse. So I'm going to give you a minute to do Pythagorean theorem. Go ahead and square those out, subtract, and we'll see if we come out to the same answer in the end. So you get 21.75, but remember to square root it. And whenever we square root it, we get that x is about 4.66. Okay. Now I need to be careful because that's not the perimeter. In fact, 4.66 isn't even the full side. 4.66 is just that part of it. So if we asked ourselves, what's the full side? So 4.66 times 2, that'd be 9.32. And then ask yourself, how do we find the perimeter from there? So if we kind of backtrack, most of these problems are really, they're really nice. They give you the apothem, they give you a side, so we can quickly find the perimeter. For the hexagon, we had to do a little bit of work. And sometimes for problems like this, you're missing a value, but we can do Pythagorean theorem and figure it out. So if I know that one side is 9.32, I'd use Pythagorean theorem to find this piece, and then I doubled it because that was just half of a side. So if I do everything correctly, I should get that the perimeter is 46.6. And I did have to do some extra work on that one, but not too much. So now I'm just going to go to the calculator and I'm going to type in 0.5 is a half. So you can do 6.5 times 46.6 divided by 2. Or you can do 0.5 times this. Either way, you should be able to get out to the answer, which is 151.45 units squared. That's it. So taking a look at this next one, I'm in a bit of trouble on this one. I want you to think for a minute. Why do we have some trouble on this one? Well, if I go to find the area of this particular shape, remember we need the apothem and the perimeter. And for this particular problem, I don't have either one. But we do know that this is a hexagon, and remember that if it's a hexagon, that whatever this radius is, that's what our side is as well. So all of our sides are going to be 8, so that's going to help me find the perimeter. Now let's go back and actually look for a pattern on this previous one that we had. Okay, if you notice we had 20, 20, 20, and then half of 20 would be 10 root 3, and that's because with all these equilateral triangles, whenever we cut them in half, we end up with 30, 60, 90s. So my other shortcut on the hexagon is to find the apothem. I can just half the radius, half the side, and then add a root 3. So back to this one, I'm going to half 8 and then add a root 3, so my apothem would just be 8 root 3. And that's kind of a shortcut. If I remember that these are equilateral, I cut it in half. That would be 30. That would be 60. So I really have a 30, 60, 90. And I could do my little chart with the 1 and root 3 and 2. Or if we just remember that if that side is 8, then this side should be, it should be 4 root 3. I'm sorry there. So we half it. So going back, if this is 20, then that would be 10 root 3. So if this is 8, it would be half, which would be 4 root 3. And once I've done that, now I have enough information to find the area. So area equals 1/2. The apothem was 4 root 3. I used that shortcut. And the perimeter is not 8, but it's 8 times 6 because it's a hexagon. So 8 times 6, or if I added all the sides, that would be 48. And remember, what's out stays out. So if you do want to go to the calculator, you can do half of 4 in your head and then just do 2 times 48. And what's in stays in, so that would be 96 root 3 units squared. And that's it. Now we're going to skip these last two problems, and if you look at both of these, on this one, ask yourself, what's missing on this pentagon? What would we need to find the area? Well, we're missing the apothem on the pentagon. If I look over here asking ourselves, what shape is this? Well, that has 9 sides, so that would be a nonagon. And in the nonagon, I'm missing the length of the side, so I can't find the perimeter. So we are going to skip those last two problems. Most of the time you'll have the apothem in the side length to find the perimeter. Worst case scenario, you can always use Pythagorean theorem to find it. And that's it for today's lesson. Good luck on your practice.